Well, hi everyone, I'm Bonnie and I'm so excited to be right here sharing with you. First, a little bit about me. I'm a Christian, I'm from Guatemala, and I work on the Innovation Lab of Universidad Galileo as research assistant. I'm studying computer science there too. I'm co-lead on the new Facebook Developer Circle in Guatemala. Woo! We are starting right now with the Dev Circle. I'm a React and Node fan. I really like React a lot, and I'm enjoying my journey into deep learning, so I want to share it with you too. You can find me on Twitter and a little bit on GitHub, Facebook, and the other ones. And these slides will be shared on my Twitter later. So this talk is named ReacTex, using React Native and neural networks to recognize handwritten equations. Well, first, why artificial intelligence? Why machine learning, deep learning, neural networks? They become some popular names today, but they are old concepts. All of them needs a lot of computational power and tons of data. They become a reality thanks to all the improvements to the computers of today, CPUs, GPUs, parallelism, and more important, thanks to the internet. The globalization, social media, the Internet of Things. There is a humongous amount of data out there, and a part of it is for public access. Thanks to big companies, this research are accelerating. For example, Google, Facebook, NVIDIA, Intel, Amazon, all of those are helping to this research. In a demanding world of tons of information, the ones that can learn and do something with the data that is analyzed has advantages over competitors and bring better applications to its clients. There is not possible to pre-program pre-program rules to deal with the infinite combinations of input data and situations that appear in the real world. So please forget the if and else statements a little bit. So for that, here comes deep learning. There is lots of applications. The most popular ones are visual recognition to detect some objects, places, and people on a photo or a video. There is speech recognition that is used by the assistants like Siri, Cortana, and the Google Home. There is natural language processing, like the chatbots that could bring a more efficient experience to the users, like the API of Messenger that is building Facebook. There is the sentiment analysis that can help to collect opinions about the products or services. It's really useful if you want to know the feedback about your clients, your users. Generating new content like images and videos. For example, style transfer. There is a photo of me trying to transfer the style of the famous painting The Scream to my photo. It's look pretty likely. Yeah. And there is other projects like the Deep Dream, that there is a link of the project if you want to see it, and another project that is named Pix to Pix, that the people draw and it generates a face between the drawing. As well as we can use deep learning to empower our React products, also we can use React as briefcase of our research and projects. For example, here is a screenshot of a project that is of a style transfer that I made for the Innovation Lab that I'm working on, where the user could take a picture and then apply a style transfer to the photo. All the front end was made with React. Deep learning seems pretty cool and powerful, but how do we start learning? The first step is understand how it behaves. To start, I recommend you to use APIs. There is lots of them. For example, Watson from IBM. It has different services like the vision recognition and the natural language classifier. There is too the Google Cloud APIs. They have a lot of them. For example, the vision and speech recognition or the bit intelligence. They're really cool. The most important thing when you are learning is to try yourself the things, so do it yourself. So I encourage you to build little projects to practice. It's not the same only read and view videos than code and run it yourself. In that way, you will learn in a more easy way. In that photo, I was trying the facial detection of Google Vision API. With an HTTP request, we send the photo and the API answers with a JSON. With a JSON file with coordinates of the parts of the face. So using Node Canvas, I draw triangles and other forms figures on my eyes and mouth, and with the API information, I detect that in the photo I was happy or sad. Then start with the learning materials. There is a lot of tutorials, courses, books, video lectures on the internet. The ones that I recommend you are the Udacity Deep Learning Nano Degree, and Andrew NG is releasing a new deep learning specialization course. And follow Siraj Raval on YouTube. He's teaching in a more practical way and do coding tutorials that are really useful. He will help you a lot with the practical one, all the coding. When you start learning, it's a little bit difficult, so I want to help you with some basic concepts. So first, an artificial neural network are the learning algorithms that is used on deep learning. This model is inspired on our biological brains. When we are learning something, for example, a new programming language, first, we seek for information. We do tutorials, read books, view videos, and then we practice to do it better. With the neural network, it's similar. We give it data and then train it. So the neural network could learn something, and even more training, it will become better, like us. When we have luck, there is a teacher or mentor directly helping us to learn. That is named supervised learning. We give to the neural network a set of data and labels to give it feedback of what is correct and what not. Then could do some tasks like classification. For example, we can classify images of dogs, of different dogs, give it a label, dog, 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 and then try to ask if the neural network understands with a new photo if that is a dog. Other type of learning is unsupervised learning. We give it a bunch of data without labels and has to find by its own the structure of the data. It's really useful to find patterns. For example, users that are doing they are doing bad things with your software, you can find with this type of learning. And the other type is reinforcement learning. The neural network interacts with an environment only getting feedback if achieves some goal. In a process of trial and error, use it to give a task. For example, use it to give a task to a bot. And another popular implementation of this are the self-driving cars or the video games. But there is a lot of applications that we could use it on our products. During the talk, I will be using supervised learning, the first one that I said. Now, we know that we need data and labels, but how is a neural network? There is a lot of architectures. For example, feed-forward, convolutional, and long short-term memory. The most basic one is a perceptron. The biological neuron, a biological neuron receives a signal from each of its dendrites, then integrate all the signals, and if past a certain threshold, send the new signal through its axon to the next neurons. An artificial neuron imitated. It has inputs, then multiply it with the weights, sum all the results, and apply an activation function. Then could send the data to the next neurons. If we connect multiple neurons, we create layers. The input layer receives the data. The hidden layers process the information. And the output layer classify using probabilities. This is a fully connected feed-forward neural network. We could represent objects of the real life as numbers and label it. On the input layer, represent certain characteristics with numbers on each neuron. On the output layer, represent with ones and zeros which category belongs the objects that you are representing. Then compare the final output with the label that you are expecting to calculate the error. We want to minimize this error. For that, we use something named gradient descent. Gradient descent is search local minimum of a function. The partial derivative that is in the red arrow, the partial derivative finds the direction to get down, and each step size is determined by the learning rate. If the learning rate is too big, it will never find the minimum error. If the learning rate is too small, it would take too much time to train it. Multiply the gradient by the learning rate to get the step to update the weights. Updating the weights is named backpropagation. We tell from the output to the first set of weights, we are telling the neural network what was wrong. It's like if we wanted that it says a 1 and it says a 0.7, we say, no, you are doing wrong, and then go and tell all your friends that you are doing wrong, and fix it, please. That is backpropagation. Well, repeat it until the errors get minimum. This is a little bit of the math. It seems pretty awkward, but when you are coding it, it's pretty simple. The neural network are represented by tensors. Each layer is a vector, or one-dimension layer, one-dimension tensor, and the weights are matrices of two-dimension tensor. And to feed forward the information, we do matrix vector multiplications. When the neural network has many hidden layers, they are named deep learning neural network. Okay, we review some neural network concepts. I want to help you with that, so we do the neural network concepts. So I recommend you to try to implement a simple neural network from scratch. Try it. That will help you to understand all these concepts more easily. It's better if you use Python to do it, but it's possible on most of the programming languages. I already do it with JavaScript and was really funny to try it. You can learn by example, trying models that are already trained. There are lots of them on GitHub. You can try to find them, download it, and try it yourself. And there is some funny ones. For example, this of the style transfer. You can try and style transfer some of your photos. There are other ones, for example, a Flappy Bird that can learn by itself how to play Flappy Bird. You can try all of them. That's impossible. Yeah, it's impossible for us to play Flappy Bird, but for the neural network, not. Then you could try some libraries or frameworks that will make neural networks easier to implement, train, and use for production. For example, TensorFlow, Caffe2, Keras, and H2O AI. Keras and H2O, they are frameworks. They simplify the part of coding it and uses in the background TensorFlow or Caffe2. TensorFlow is more used when you understand better what are you doing. But if you just want to use it, I recommend you to use Keras. Okay, let's go with the project. This is a continuously evolving project that I'm doing, and I will show you a simplified version of the project ReacTex. Okay, LaTeX is the standard of writing scientific and academic papers. So the idea was to create an equation editor with LaTeX output more easily to use. If you see there, there are all the tags that we have to write to form an equation. And that is the form that we see it with the render. See, writing the equation is a little bit complicated, right? So we want to create user-friendly interfaces for the users. And the most natural way to write a symbol is handwritten. But how we know what wrote the user? With handwritten recognition. First, we need to transform our data. Online recognition is when we get the paths of the symbols and the drawing times, but there is too many orders to draw a symbol. For that, we'll need a lot of more data. For example, this pi symbol, it has many forms to draw it. There is another type of representation that is named offline recognition. We analyze the symbol like an image, representing each pixel as a number between 0 and 1, where 1 is totally black and 0 is empty. That is named a bitmap. If you see it, there is a 7 on there with the 1s, and that is the real form that we'll see it. It's more pretty one. This is the most pretty one. For the drawing canvas, I use React Native. I use a React Native SVG using the path component to get the user input. Then I transform the drawing into a bitmap. See? For the neural network, I use TensorFlow. Here's a little piece of code for this example that I left here. Is using 2 hidden layers, and then I train the neural network. It seems pretty cool with TensorFlow. The equation editor was made for the web using React. I use React LaTeX for the LaTeX render. Thanks to React, each of the symbols is a clickable object, making the edition easier. If you see, you can click it, and when you draw the 7 on the React Native application, they will send it to the web and write it on the equation. Right there. See? It's right in the 7. Yeah. And then I used TensorFlow to the neural network. Here's the part when it's on production. And then I connect the 3 pieces of the project with Node. This project was really funny to do it. Thanks to React, I could have some visual for the user that is more easy. With TensorFlow, I do all the part of the neural networks, and React Native give it to the user a more easy way to write, that is the handwritten. So I encourage you to try the deep learning things, all that kinds. There is another part that is named machine learning, that is predictions that it may be useful to predict some things on your products. So thanks for listening and have a happy learning.